Okay, once again, I welcome you to my YouTube channel. Remember, my name is Commander Vlogger, popularly known as Guido Academy. So in this particular video, I'll be explaining the Dalton's atomic theory. Dalton's or Dalton atomic theory. That's what I'll be explaining in this particular video. And before that, first of all, if you hear the word atom, what's come to your mind? Those days, we believe that atom is more or less indivisible part of an element, or atom is any substance at all that cannot be broken, that cannot be divided. So then, I'm talking about those days in Greece. Please, in Greece, if there is something, for example, if this marker, if you can't break this marker into simpler parts, this marker is called an atom. Take note of that. If this marker cannot be broken down into simpler parts, we refer to this marker as what? As atom. So anything at all, even if you break this marker, the smallest part of this marker cannot be broken down. So that smallest part of that thing that cannot be broken down is referred to as what? As atom. That was then. And atom was discovered by a man called Democritus. This was the name of the man that discovered atom. But some people said it's not Democritus, it is John Dalton. But the truth is that John Dalton was the first person that postulated about atom, while Democritus was the one that brought the whole stuff atom. So according to John Dalton, he said atom is got from a Greek word called atomos, which means cannot be broken down. So anything like what I said earlier, anything also that cannot be broken down, that cannot be splitted, is called what? Atom. And he proposed 5 theories, and this 5 theory is called the Dalton's atomic theory. Dalton's atomic theory was proposed by a man called John Dalton. According to the Dalton atomic theory, he proposed 5 theories. The first one stated that atom can neither be created nor destroyed. He said you can't create atom and you can't destroy atom. But currently, is that true? No. Please, Dalton's atomic theory was proposed years back, and currently we are not working with his theory. His theory has been modified already. So the second one states that all elements are made up of small indivisible particles called atom. So all elements are made up of small indivisible particles called what? Atom, which is not even true. Then the third one states that atoms of the same element are exactly alike in every aspect and differs from atoms of other elements. Atoms of the same element are exactly alike in every aspect and differs from atoms of every other element. Now, this thing here is not also true, but then it was accepted, but currently it's no longer accepted. So the fourth one states that when atoms combine together, they do so in simpler ratio or smaller ratio. Let me use simpler or smaller ratio. So, but the truth is that currently, there are some kind of reaction that will take place whereby they don't even do that in smaller ratio. For example, let's say H2O now, here is 2:1. This is what he was saying. CO2, this is a 1:2. So these are smaller ratios. But when you now enter organic chemistry, probably when we go to the modification of atomic theory, I'm going to explain all those things deeper. Then number 5, all chemical change results from the combination. All chemical change results from the combination of the separation of atom. So chemical change only occur from the combination or the separation of what? Of atom. So this was the theory that John Dalton proposed as a dead. Like what I said earlier, John Dalton was the first person that proposed about atomic theory, and the word atom was gotten from Greek. It's a Greek word. And the word is what? Atomos, A-T-O-M-U-S, which means it can neither be created nor destroyed. But the major one now, atom means indivisible. So anything that is not divided, cannot be divided, is called what? Atom. Okay, let us go through some of the modification of Dalton's atomic theory. So the first one states that, remember, they said atom can neither be created nor destroyed, but can be converted from one form to another. But it was contravened, which is it was, in the real sense, atom was destroyed and it can also be created. For example, let's say this is uranium atom. Here is 238 and here is 92. It's going to give us 234. Here is 90 thorium plus what? An alpha particle that will be emitted. plus energy that will be radiated. So in this situation, now that's to say it is true that atom can be created, and it is true that uranium was also what destroyed to give us other atom. So that's to say the first one was what was contravened using radioactivity. The other thing again, they said atom of same element, they are usually alike in every aspect. No, hydrogen can be hydrogen 1 1, can be hydrogen 2 1, can be hydrogen. So these three, they are not alike in every aspect. Mass number differs already. So this thing here was contravened by what we call what isotopy. Then the last one we have there, combination between atoms can take place in smaller ratio, which is usually not true. Like what I said earlier, H2O here will be 2, here will be what 1. For some cases, you not really see all these smaller ratios, you not see them. Most especially if you are dealing with organic molecule. So this was contravened by what organic molecule. And how do I explain that? There's a concept in organic chemistry that is called catenation. And catenation is the ability of organic compound or carbon or any molecule at all, but because of organic chemistry, let me trace it to carbon, to form a straight chain, a branch chain, or a what? A cyclic chain. So the first one was contravened by radioactivity, the second was contravened by isotopy, while the last one was contravened by what? Organic molecule or catenation. I've talked about some stuff regarding which is Dalton's atomic theory, then the modification of Dalton's atomic theory. So now let's talk about the atomic structure. So what does an atom look like? So this is a shell, this is the nucleus. The nucleus consists of two particles again. One of them is charged while the other one is not. The one that is charged is called proton. The one that is not is called neutron. Why there is another guy again that revolves around the nucleus that has a negative charge. It's called the what? Electron. Please take note of this. The proton and the neutron, they are found in the guy called what? The nucleus. So, and electron and the nucleus, they are found in what we call the what? The atom. Please take note. Atom is not the smallest indivisible part of an element, because if atom was the smallest indivisible part, we won't have electron, we won't have proton, we won't have neutron, we won't have, there are other smaller particles again inside. Electron is not even the smallest, proton is not even the smallest, neutron is not, we have other smaller particles. An atom generally, I'll be going deeper with time, but let me bring this in. Those days when it was said that atom cannot be divided or is indivisible, there is this guy called J.J. Thomson. We have J.J. Thomson, we have Ernest Rutherford, we have Eugene Goldstein. There are more. They contributed to the discovery of this whole stuff. But we are going there immediately after the structure of an atom. So please take note. This is the structure of an atom. What happens to this electron? It revolves around the nucleus of the atom. Electron revolves around the nucleus of the atom. Proton is positively charged. Electron is negatively charged. Neutron is neutral, while the nucleus itself is positively what? Charged. So that is everything about the atomic structure. Okay, these are some of the things I want you to know in terms of contribution to the atomic theory and all that. So the first one, Faraday's work of electrolysis shows the evidence of electron. So a question might come like this in your exam. The reason why I have to arrange them like this, so that how the exam question will be set. That's just the reason. So a question will come in this format: which of the following scientists shows the evidence of existence of electron? So the answer is what? Faraday's work of electrolysis. So it was Faraday's work of electrolysis that showed that truly there is something we call what? Electron in an atom. So the second one we have the Crook and Parker observe that glows existed around a cathode, and this experiment was kind of related to the proton. Then the third one we have the J.J. Thomson found the electron mass ratio to be this. Please take note. The electron mass ratio was proposed by who, or was discovered by who? The answer is J.J. Thomson. And what is the value? Is 1.76 exponential 8 coulomb per what? Per gram. Then from there again, if they ask you what is the charge of the electron, the charge is minus 1.60 times 10 times 10 raised to power 19 coulomb, while the mass is 9.11 times 10 raised to power 28 gram. So, and this was proposed by Harry Millikan. So Harry Millikan conducted the oil job experiment, and he found this to be the charge, and he found this to be the what? The mass. So the charge is minus 1.6 exponential 90 coulomb, while the gram or the mass is 9.11 exponential 28, not 25, 28 what? Gram. Then the next thing is Eugene Goldstein discovered the proton, the positively charged particle was discovered by Eugene Goldstein. Then James Chadwick discovered the neutron. So the guy that discovered the neutron is called James Chadwick. Then Roentgen discovered the X-ray under radioactivity. Becquerel and Marie Curie discovered radioactivity. So please take note of Roentgen and then Becquerel, then Marie Curie. So these are the two persons that discovered radioactivity. Then as for the next one, Ernest Rutherford discovered the nucleus. Please take note. Ernest Rutherford discovered the nucleus, while James Chadwick discovered the neutron. What about this guy again? Eugene Goldstein discovered the proton. So please take note of this. And it was this guy, Ernest Rutherford, he was the one that bombarded the nucleus of an atom. So when he bombarded the nucleus of an atom, that was how you bombarded atom rather. That was how the whole thing split out. Then Austin was the one that discovered isotopy. I wrote this as the last one because there might be a calculation question on isotopy whereby they tell you to calculate the relative atomic mass. So if you are calculating the relative atomic mass of any isotope, your formula should be M1 A1 plus M2 A2 all over A1 plus A2. Where this your M1 here is the mass of the first isotope, abundance of the first isotope, mass of the second isotope, abundance of the second isotope. A1 is what's it called? Abundance of the first isotope, abundance of the second isotope. So please, everybody should take a look at this whole stuff again. If you have any questions regarding any of this, feel free to drop that in the comment section. But before we call it a day, I want to give you a calculation question on isotopy. Okay, let us take a look at this. This is a calculation question on isotopy. And like what I said earlier, the formula is relative atomic mass is equals to M1 A1 plus M2 A2 all over A1 plus what? A2. So whereby I told you that M1 is the mass of the first isotope, A1 is the abundance of the first isotope, mass of the second isotope, abundance of the second isotope. So calculate the relative atomic mass of Y. If Y exists in two isotopic form, the first isotopic form is 39Y, while the second one is what? 40Y. So if you want to do this, what is the abundance of the first isotope? We have 2 ratio what? 3. So the first isotope is 2, the second isotope is what? Is 3. It can also be in percentage, it doesn't matter, maybe 10 to 20, 10. If here is 10%, therefore this one will be 90%. So it can be percentage, it can be whatever. But what you should take note of is that this formula will definitely work for any calculation question you are looking for. So what's my first mass here? The first mass here is 39. 39 times abundance is 2 plus mass 40 times what? 3. Then at the end of the whole thing, A1 is 2, then A2 is 3. Then from there, if you punch your calculator, 39 times 2 will give us 78 plus 40 times 3. 40 times 3 will give us 120 all over 5. So let's punch our calculator again. 120 plus 78. We have 198 divided by 5. Then if you divide your answer by 5, you are going to have something like 39.6, which is option B. So you can try this yourself if you are going to get the same answer. Please take note. Mass of the first isotope, abundance of the first isotope, mass of the second isotope, abundance of the second isotope, A1, A2. So that's just it. You do this, then you get your answer. What about if you are told to solve something like this? We have boron 10 and boron 11. Then the boron 10 has 20% abundance, while this has what's it called again? 80% abundance. So if it is 20 to 80, which is 20 ratio 80, can also be simplified. 0 cancel 0, we are left with 2 ratio 8. 2 go 1. So here is 1 ratio what? Ratio 4. So if you use 1 ratio 4 to solve, you are going to get the same answer. If you use 20 and 80 to solve, you are still going to get the same answer. So please, I want to beg you all, try this. If your answer is option A, drop in the comment section. If your answer is option B, drop in the comment section. If your answer is option C, drop that in the comment section. If it is D, drop that in the comment section. Please subscribe to Guido Academy, share this video to others, and don't forget, share this video, give this video a thumbs up, share it to your departmental group chat, your faculty group chat, every group chat groupable. Send this video to that your group chat. Encourage others to watch videos from my YouTube channel. I hope to see you in the next episode. But for now, goodbye.